So in the morning class, we did problem based on orthonormal basis. Now also we continue with the same topic. In the next class, we say about it, the last topic, least square approximation. Okay? So here also we are going to do one problem from orthonormal basis. Suppose it is a polynomial form. If it is a polynomial form, how we can find out orthonormal basis? The question is, let V be the set of all polynomials, the set of all polynomials of degree less than or equal to 2 over capital R with inner product defined by inner product of f comma g equal to integral 0 to 1 f of x g of x dx starting with the basis mentioned 1 comma x 1. Question is obtain an orthonormal basis for V. Orthonormal basis for V. So similar of this problem we did in the morning, but it is little different here. See it V be the set of all polynomial of degree less than or equal to 2. So vector space is what here? It is polynomial of degree less than or equal to 2. That is we understood. The over or means the in the polynomial coefficient or real number, not a complex number. With inner product defined by, so what it is defined, inner product of f comma g comes integral 0 to 1. The previous problem actually it was integral minus 1 to 1. Okay, the question is similar, but the limit is different. It is 0 to 1. The previous one is minus 1 to 1. So how it is defined? Inner product of f comma g is f of x into g of x dx starting with the basis. Suppose already I told you, suppose basis is not mentioned in the question, you consider, okay, you consider the basis because it is a polynomial of degree less than or equal to 2. Polynomial of degree less than or equal to 2, basis is actually 1x square. So suppose polynomial of degree less than or equal to 3 means it is actually basis are 1x square x power 3, like that. So using the basis, calculate orthonormal basis for V. So before finding orthonormal basis, we just calculated orthogonal basis, right? So first to find out, so here I am writing that the solution to find now orthonormal basis for V. Orthonormal basis for V we are going to find out, but before that we need orthogonal basis. Okay, so first to calculate it, first to find orthogonal basis. Orthogonal basis is what? W1, W2, W3 for V. Then only we can write it orthonormal. That is very simple. One more step only. We just find out W1, W2 and W3. So given, what is given? The basis v1 is equal to what it is given? 1. v2 is equal to x. v3 equal to x square. These are the values are given. v1, v2 and v3. Then it is given inner product of f comma g is integral 0 to 1, right? So also given that inner product of f comma g is actually how they have defined integral 0 to 1 f of x g of x dx, integral 0 to 1 f of x g of x dx. So we follow 3 steps for finding w1, w2 and w3. The first is step 1. Step 1, what we take it? Let w1 be v1. Initially, w1 be v1. v1 is what? It is 1. So what is w1? w1 is equal to 1. Take it, this is number 1, equation number 1. So w1 we calculated, then we need to find out w2. That is the step 2. Second step we follow it. So finding w2. So we follow the formula v2 minus inner product of v2 comma w1 by norm w1 square into w1. So what is the formula? w2 is equal to v2 minus inner product of v2 comma w1 by norm w1 square by into w1. Okay. So v2 is we know. v2, what is v2? It is given. v2 is equal to x, right? You can substitute it v2 by x here. And we need the answer for inner product of v2 comma w1. And also we need that norm w1 square. Okay. So inner product of v2 comma w1. So how we find out v2? Substitute it. v2 is x. w1 is what? It is 1. So inner product of x comma 1. So we know that inner product of f comma g, how it is defined in that question? Integral 0 to 1 f of x g of x dx. Okay, this is inner product of f comma g. So it is actually comparing that f of x, this will be g of x. So inner product of f comma g, that is the meaning. Therefore, inner product of v2 comma w1, this answer can be written as integral 0 to 1 f of x place put x into 1 dx. Okay, f of x is x, g of x is 1, we have substituted. Now we know how to integrate it, x dx. So integral x dx, what is the integral answer? So x power n comes, x power n plus 1 divided by n plus 1, right? So using the standard result, x power n, so it is x power 2 divided by 2, right? Integral x power 1 meaning, so x dx integration is x square divided by 2. So it is the limit 0 to 1. So therefore, applying the limit, upper limit, it is actually substituting x by 1, right? So substituting x by 1, this answer is actually 1 square by 2 minus lower value substitute x by 0. So 0 square divided by 2. So what is the answer? 1 by 2. So inner product of v2 comma w1 answer is what? 1 by 2. Okay. So then also we need that norm w1 square. Norm w1 square. So what is, find out norm w1 square? What is the formula? Inner product of w1 comma w1. This is norm w1 square. Norm w1 square is what? Inner product of w1 comma w1. So what is w1? 1. 1 comma 1. So now also apply it, the formula. Inner product of f comma g means integral 0 to 1 f of x into g of x. Integral 0 to 1, 1 into 1 dx, right? F of x is here 1, g is 1. Okay. So therefore this can be integral 0 to 1, 1 into dx, it is dx only, right? Integral 0 to 1 dx. Integral dx is what? Integral dx, this is x, right? So 0 to 1. Apply it limit now. Upper limit, it is 1. Substitute x by 1. Minus of lower limit, substituting x by 0. It is 1 minus 0. So what is the answer? 1. So therefore, norm W1 square answer is what? Norm W1 square answer is 1. Okay. So we calculated inner product of V2 comma W1. Also norm W1 square. Therefore, write it answer for W2. So therefore, W2 answer is, formula says V2 minus inner product of V2 comma W1 by norm W1 square into W1. So substitute V2. V2 is what? It is x. V2 is x. Because V1 is 1, V2 is x, V3 is x square. So this is x minus inner product of V2 comma W1. V2 comma W1, we found it is 1 by 2. So therefore, 1 by 2 divided by norm W1 square, it is 1, right? This is 1. And W1 is also 1 into 1 only. So what is that? X minus 1 by 2 divided by 1 into 1. The answer is 1 by 2. So what is W2? It is, take it a number, equation number 2. So W2 answer, we got it, it is x minus 1 by 2. So similarly, find out W3 also, because there are 3 bases, V1, V2 and V3 it is given. So need to calculate it, W1, W2 and W3. So W1 and W2 is just over to find. It is the third step. Step 3, to find W3. To find W3. So what is the formula for W3? Do you remember W3? W3 is actually, the formula says, just extension, right? V3 formula is, what is that? V3 minus inner product of V3 comma W1 by norm W1 square into W1 minus inner product of V3 comma W2 divided by norm W2 square into W2. See it, very simple formula. W3, it is starting from V3, okay? W3. W2 means V2 minus. W2 means V2 minus. W3 is actually V3 minus. So V3 minus inner product of, starting again V3 comma first vector W1 by norm W1 square into W1 minus inner product of V3 comma W2 by norm W2 square into W2. In this, V3 is, we know, it is given V3 equal to x square only. Then inner product of V3 comma W1, we have to calculate it now. And norm W1 square already we found, it is 1. W1 is also, from the first step we can collect it. Then inner product of V3 comma W2, we need to calculate it. Then norm W2 square. So therefore, to find W3, we need these 3 values now. So first to find out V3 comma W1. Inner product of V3 comma W1. So what is that? V3 is what? It is x, right? So x, we need actually norm W2 square. Here we find out. Okay. So V3 is x, x square. V3 is x square. V1 is 1. V2 is x. V3 is x square. W1 is actually 1. W1 is 1. It is in the form of inner product of f comma g. It is in the product actually. It is in the form of inner product of f comma g. So find out, this can be integral 0 to 1. The formula says f of x into g of x dx. This is f of x and g of x. Integrate it now. Integral 0 to 1 x square dx. So what is the integral answer? X power 3 divided by 3, right? Limit is 0 to 1. So applying the limit, 1 power 3 by 3 minus 0 power 3 divided by 3. What is the answer? It is 1 by 3. So inner product of V3 comma W1 is equal to, what is the answer? 1 by 3 we calculated. Norm W1 square already we found it is 1. Now we need to calculate inner product of V3 comma W2. Inner product of V3 comma W2 find out. So this is actually V3 value is actually x square, and W2 from the second equation it is x minus 1 by 2. W3 is what? X minus 1 by 2. So substituting here x square into x minus 1 by 2. So now this can be integral 0 to 1 f of x into g of x dx. So x square into x minus 1 by 2 into dx, right? So before taking integration, multiply it. X square into x, this will be x power 3 minus 1 by 2 x square into dx. Okay. So now find out the integral answer. The integral answer is x power 3. What is the integral of x power 3? This will be x power 4 by 4 minus 1 by 2. X square integration is x power 3 divided by 3. Limit is what? 0 to 1. Applying limit 1 power 4 by 4 minus 1 by 2 3s are 6, take it into 1 power 3. This is upper limit minus lower limit, substituting x by 0. So 0 power 4 divided by 4 minus 0 power 3 divided by 6. So taking the simplification now, this is equal to 1 by 4 minus 1 by 6. The lower limit values are 0. Lower limit values are 0, right? 0 power 4 and 0 power 3, all that values are 0 now. So 1 by 4 minus 1 by 6 is what? Let us take it LCM. 24 is the LCM. Then 6 minus 4, right? So the answer is 2 by 24. Answer is 1 by 12. So the answer for inner product of V3 comma W2. Inner product of V3 comma W2. This answer is actually 1 by 12. Okay. So then we need one more value. That value is actually W2 square now. W2 square. So W2 is x minus 1 by 2. Okay. So find out a norm W2 square. So norm W2 square is actually inner product of W2 comma W2. Inner product of W2 comma W2. So this is substituted. W2 is x minus 1 by 2, right? X minus 1 by 2 comma x minus 1 by 2. Take it the limit integral 0 to 1 f of x into g of x dx. So x minus 1 by 2 into x minus 1 by 2 into dx. Okay. So finding the simplification before taking integral, this will be integral 0 to 1. So x minus 1 by 2 into x minus 1 by 2. Find out the multiplication. Okay. So it will be x into x square minus 1 by 2 x minus 1 by 2 x 1 by 2 into 1 by 2. This is plus 1 by 4 into dx. Again, this is equal to integral 0 to 1 x square minus x by 2 half, right? So it is minus x only, right? Minus 1 by 2 minus 1 by 2 is minus 1. So this is minus x plus 1 by 4 into dx. Now easily we can take the integration. So integral x square dx is 6 power 3 divided by 3 minus x power 1 meaning, so it is x square divided by 2. Then the constant term integral answer is 1 by 4 into x. Limit is 0 to 1. Apply it limit now. So this is equal to upper limit is 1 now. It is 1 power 3 divided by 3 minus 1 square divided by 2 plus 1 by 4 into 1. It is upper limit minus lower limit substitute x by 0. So this is 0 power 3 divided by 3 minus 0 square divided by 2 plus 1 by 4 into 0. So actually the lower limit value is equal to 0, right? So here the answer is 1 by 3 minus 1 by 2 plus 1 by 4. So take it simplification 1 by 3 minus 1 by 2 plus 1 by 4. You can take it LCM 12. So 4 minus 6 plus 3, right? So this is actually 7. Sub 4 plus 3 is 7. 7 minus 6, it is 1. 1 by 12. So therefore answer for norm W2 square. Norm W2 square answer is what? It is 1 by 12. So now we can write it the answer for W3. So W3 is what? V3 minus inner product of V3 comma W1 by norm W1 square into W1 minus inner product of V3 comma W2 by norm W2 square into W2. So substituting all values V3 is what? X square, right? Minus inner product of V3 comma W1. So which is we calculated V3 comma W1. Inner product of V3 comma W1 is 1 by 3. So it is 1 by 3. And the norm W1 square value is 1. W1 is also 1 minus inner product of V3 comma W2. V3 comma W2, we calculated this value. V3 comma W2 is 1 by 12, right? Inner product of V3 comma W2 answer is 1 by 12. So therefore, put inner product of V3 comma W2 answer is Next. So this is 1 by 12. So 1 by 12 divided by norm W2 square. It is just now we calculated. It is also 1 by 12. So 1 by 12 into W2. So W2 is x minus 1 by 2. Okay. So take it simplification x square minus 1 by 3. 1 by 12, 1 by 12 will be getting cancelled. Minus of x minus 1 by 2. Again, finding the simplification. This is equal to x square minus 1 by 3 minus multiplied minus 6 plus 1 by 2. So this can be x square minus x minus 1 by 3 plus 1 by 2. So 1 minus 1 by 3 plus 1 by 2. This answer is actually x square minus x taking minus 6. So we get the answer for minus 1 by 3 plus 1 by 2. Take it LCM. The answer is 1 by 6. So W3 we calculated. The answer is x square minus x plus 1 by 6. Now we can write it orthogonal basis and also orthonormal basis. But we need a norm W3 square value. So therefore, before writing the solution, we just find out norm W3 square. So norm W3 square is what? Inner product of W3 comma W3. Inner product of W3 comma W3. So put W3 by, this is equation 3 from 3. X square minus x plus 1 by 6 comma x square minus x plus 1 by 6. So it is norm W3 square. Therefore, this will be inner product of f comma g only. Applied inner product of f comma g. So integral 0 to 1 f of x into g of x. So x square minus x plus 1 by 6 into x square minus x plus 1 by 6 into dx. Okay. So then find out simplification. Multiply it, that two brackets. After that, take it integration with respect to x. So this is equal to integral 0 to 1 multiplying the bracket, x to the power 4 minus x to the power 3, x square into x, plus 1 by 6, x square. Then the second term multiplication is minus x cube plus x square minus x by 6. Then the last term multiplication is 1 by 6 x square minus 1 by 6 x. Then 1 by 6 into 1 by 6, 1 by 36 into dx. So now again a simplification needed. So this is equal to integral 0 to 1. Only 1 x to the power 4. So write it x to the power 4. X cube minus x cube minus x cube. This will be minus 2 times x cube. Then 1 by 6 x square, 1 by 6 x square. Actually 2 by 6 x square. Plus 2 by 6 x square. Again one more x square is there, plus x square. Then x by 6 minus x by 6. Right? So minus 2x by 6 plus 1 by 36 into dx. Just a simplification only. This is equal to now integral 0 to 1 x to the power 4 minus 2x power 3. 2 by 6 x square plus x square, here we can cancel it 1 by 3. Again taking LCM, 4x square by 3 plus 4x square by 3. Again this is cancelling that, minus x by 3 plus 1 by 36 into dx. Now easily we can take the integration, right? So integral answer is actually so check it, minus 1 by 3. Okay. So now integral x to the power 4 integration is what? What is the integral? X to the power 4 is x to the power 5 by 5, right? X to the power 5 by 5 minus 2 x to the power 4, 4 plus 4 by 3 into x cube divided by 3 minus 1 by 3. X integration is x square divided by 2 plus constant term plus 1 by 36 x. Limit is 0 to 1. Applying the limit now. So we get the answer for norm W3 square now. So this is equal to, put x by 1. So 1 by 5 minus, cancelling that, 1 by 2. Then plus 4 by 9, right? Plus 4 by 9 minus 1 by 6. So substituting x by 1, we get the same value, 1 by 36. Then the lower limit, applying x by 0, first term becomes 0. Second term, third term, all the values are 0. So this is actually, this will be taking LCM. 1 by 5 minus 1 by 2 plus 4 by 9 minus 1 by 6 plus 1 by 36. Take it LCM 180. Okay. So actually 36 minus 90 plus 80 minus 30 plus 5. So finally the answer is 101 by 180. So now W3 square answer is what? 1 by 180. Now we can write the conclusion. The conclusion is orthogonal basis. Orthogonal basis is, so what is that? W1, W2, W3. Write all these answers. So that is W1 is actually 1. W2 we calculated x minus 1 by 2. W3 answer is x square minus x plus 1 by 6. So this is orthogonal basis. The 4 orthonormal basis. Orthonormal basis is. So what is the formula? W1 by norm W1. W2 by norm W2. Then W3 by norm W3. So this is orthonormal basis. We calculated norm W1 square, norm W2 square and norm W3 square. So here we need norm W1, norm W2, everything. So therefore here take it as square root. Okay, so that is orthonormal basis is actually 1 divided by norm W1 is 1 only. Then norm W2 by norm W2 square. So W2 is actually x minus 1 by 2. X minus 1 by 2 divided by norm W2 square, we got it 1 by 12. So the first square root of, comma, it is 6. W3, right? W3 answer is x square minus 6 plus 1 by 6 divided by norm W3. Norm W3 is actually, just now we calculated norm W3 answer. Norm W3 square is 1 by 180. 180. Therefore, it is actually square root of 1 by 180. This is orthonormal basis. So one more step you can write it if you want to do some simplification. 1 by square root of 12. Take it as some simplification means you can do it. Otherwise, you can stop the answer. X minus 1 by 2 by square root of 1 by 12, comma, x square minus 6 plus 1 by 6 divided by square root of 1 by 180. So this is the answer for orthonormal basis, okay, for the given polynomial of degree less than or equal to 2. Okay. So the same similar problem 1x x square only we have taken, but in the previous one definition is given f of x and g of x, inner product of f comma g. It will be given integral of minus 1 to 1 f of x g of x dx. But here it is inner 0 to 1 f of x into g of x dx. So then the answer will be different. So suppose if it is in vector form 1, 2, 3 like that also, we know how to find out orthonormal basis by using Gram-Schmidt orthogonalization process. Suppose if it is in the form of a polynomial also, we know how to find out orthonormal basis. So any doubt you can ask me now. So we have one more topic in this chapter.